Good afternoon, geometers. This is a brief video over two examples that we got to in most of my classes today, but in, I believe it was fifth period, we did not reach these two examples, so I wanted to make sure you had the chance to see them as well. So, basically, here's what these are examples of. These are problems, there are two problems here that are asking me to find a missing side of a triangle, a right triangle specifically, and they're not 30, 60, 90 triangles. They're not 45, 45, 90 triangles. I don't know two sides, so I can't use the Pythagorean theorem. I have to use right triangle trig. I have to use sine, cosine, or tangent. Okay, so I wanted to talk to you about how to do that. Very first thing you want to do is figure out which angle you're looking at this triangle from. I'm going to use the angle that they gave me, which is the 27-degree angle.
Your right is waiting out front.
Okay, and that's the angle I'm going to look at this triangle from. So I determine what side is what based on that particular angle. In other words, that angle has two sides. One of your two sides of your angle is always the hypotenuse. One of the two sides of your angle is always the adjacent side. So 15 is adjacent. This side that has nothing is the hypotenuse, and that makes this side over here the opposite. So that's step one, is label your triangle according to what angle you're going to use. Step two is use that information to decide, do I need to use sine? Do I need to use cosine? Do I need to use tangent? And you're making that decision based on the fact that each of those trig functions uses different sides. So you're going to look at this and you're going to say, well, I was given the adjacent. I need the opposite. Nothing's going on with the hypotenuse. So the two sides I'm going to work with are adjacent and opposite because I was given the adjacent and I need to find the opposite. So I look at my sine, cosine, and tangent definitions and I say which one of them deals with the opposite and the adjacent. That would be tangent. So I'm going to write an equation that looks just like this but has things filled in. So tangent of my angle equals the opposite side over the adjacent side. So writing that equation is the next step. Now I just went ahead and started to do the next step, but this little line, I drew this little line because once I get this equation, to me the easiest way for most people to solve this is to think of it as a proportion because everybody knows how to cross multiply. So we're going to cross multiply. So I'm going to say 15 times tan 27 equals x times 1. I don't need to really write times 1 because x times 1 is just x. All right, now, after you have set up your equation as a proportion and cross-multiplied, sometimes x is now alone on one side. And if it's 1x, that still counts as being alone. Sometimes it's not alone. If it's alone, great, it's time to get out the calculator. Okay, if it's not alone, you have to get it alone first. So basically, after you cross-multiply, you use your basic equation solving skills to get x alone, and you don't even touch the calculator until x is alone. Now that x is alone, this is telling me what I put in the calculator to get x. So I'm going to do 15, let's see if I can get a good angle on this. I'm going to do 15 times tan 27. So 15 times tan 27. Okay, so I get 7.64 blah, 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 blah. Let's round to the nearest hundredth and call it 7.64. Now let me point out to you, it was entirely my choice to write the 15 in front of the tan 27. When you cross multiply here, you could have written tan 27 times 15. Here's what I need you to realize about that. It's fine to multiply tan 27 first times 15, but if I'm going to do that, I have to close the parentheses right here so that it's tan 27 times 15. I'll get the exact same answer. If I forget to close the parentheses, if I just type tan 27 times 15, then this is basically telling me that I am taking the tangent of an angle that measures 405 degrees because that's what 27 times 15 is. That's not what I'm trying to do. I'm trying to do the tangent of a 27-degree angle and then multiply that answer by 15. So don't do this because you'll get the wrong answer. That's the tangent of a 405-degree angle. okay? So we got 7.64, x is about 7.64, that's the squiggles indicate approximately equal to, because we rounded. It's not exact anymore once we've rounded. That's finding a missing side length using sine, cosine, or tangent. Let's go ahead and try this one. Remember, first step is figure out what angle you're going to use and label the sides from that perspective according to that angle. So that angle has two sides. This one is the hypotenuse. This one is the adjacent side. So that makes this one the opposite. So this time, when I'm deciding whether to use sine or cosine or tangent, and there's only one right answer here, I can't use anything that has an opposite in it, or if I tried to, it really wouldn't relate to the problem at hand. You know, I could try to and then maybe find this side, but that's not what I'm trying to find. I'm trying to find this side. And the information I was given is this side. So the two sides I'm working with are the adjacent and the hypotenuse. Adjacent and hypotenuse is cosine. So I'm going to write an equation that looks just like this definition of the cosine ratio. Cosine of my angle equals the adjacent over the hypotenuse. The only difference is I'm going to fill things in. So cosine of my angle is 40 degrees equals adjacent is y over hypotenuse. So there's my equation. Now I'm ready to cross multiply, and I get 18 times cosine 40 equals y times 1. Again, this is where you ask yourself, is y alone? Is my variable alone? As soon as you finish cross multiplying, you ask yourself, is the variable alone? If the answer is yes, great, pick up the calculator and put in what it tells you y is equal to. If the answer is no, then you'll probably have to divide something out of both sides to get the variable alone. This time the answer was yes. I'm ready to put 18 times cosine 40 in my calculator, and I get 18 times cosine 40, and that's 13.79. So y is approximately, equal to 13.79. And then what you are doing for your homework are the next three problems on that page. That's part of your homework, actually. That would be, in this particular case, 5, 6, and 7 on that page. Enjoy!